Dear students of the fourth year of the Faculty of Commerce, the English section, Ben Swift University, welcome back to our part 2 of the answers to exercise 1 given by Dr. عاطف of the operations research on the topic of project planning with PERT and CPM. Last time we drew the PERT network as we watched step by step from node 1 going through nodes 3, 4, 5 until we reached at the end of the project with node number 10, using just only one dummy activity with 0 duration, as you can see. Today we have to calculate 3 types of network times. The first is the early starting time for each node. We will calculate 3 times for each of the nodes, for node 1, 2, 3, all the way down to node number 10. We will calculate 3 times. The first, as I said, is the early starting time. The second one will be the late starting time, and the third, which represents the difference between the first and the second, which is the slack times for each node. First, we calculate the earliest starting time for each node. This time represents the point in time which I cannot start any activity until we reach to this time. So at node 1 we cannot start any activity when we are standing here at node 1, so the earliest possible starting time will be 0, and this will be represented using a rectangle above or near to any of the nodes that we are going to calculate this time for. So the earliest starting possible time for node 1 will always be 0. Going from node 1 to node 2, there is only one activity that will take 5 weeks, for example, will take 5 weeks. So for node number 2, the earliest possible starting times for each activity after node 2, which are F and D, will be 0, that is calculated in the rectangle at node 1, adding to it 5, which is the duration of activity A. This will give us the earliest starting possible time for activity F and D at node 2, which is 5. Going to node number 3. Node number 3 is receiving times from node number 2 and node number 1. The time that is coming from node 1 to node 3 is 0 plus 7, which is 7. And the other time that is coming from node 2 is 5 plus 6, which is 11. So which number should we select in order to represent our earliest possible starting time for node 3? We will just take a 1 minute reasoning for what node 3 represents. Node 3 represents here a starting point for each of 3 activities that are G, H, and E. If we, for example, selected the number 7 in order to write it as the earliest possible starting time for node 3. If we selected number 7, this will only allow activity B to be completed and activity A to be completed with 5 weeks, and only 2 weeks of activity D will be completed, leaving 4 weeks of activity D non-complete, which will will not meet the condition of having to wait for activity B and D to finish in order for activities G, H, and E to start. So if we selected number 7 or the lower time, this will not give much time for all the activities before node 3 to be totally completed, and will make the start of E, H, and G not possible, because they are waiting for some activities that are not yet finished. So here, in the comparison of more than one time, we will take the higher amount, which is 11, here in this case 11, to represent the earliest starting possible time for node 3. The same goes for node number 4. The node is receiving times from activity E and from activity C. The time coming from activity C is 0 plus 10, and the time coming from activity E is 11, as we selected the higher number, is 11 plus 6, which is 17. Here there is a comparison between 10 and 17, so we will select the higher duration, which is 17. Going to node 5. Node 5 is receiving times from activity F and activity G. Time from activity F is 5 plus 4, which is 9. Time coming from activity G is 11 plus 8, which is 19. So as we know, we will select the higher number with the higher duration, which is 19. We'll write it in a rectangle, like you can see above the node. So node number 6 is receiving only one time from activity H, so it is 11 plus 5, it is 16. As for node 7, it's receiving times from activity K and activity I, which will give us the 2 times 20 and the 26, and we will pick 26, which is higher duration. As for node number 8, is receiving times from J and L. From L, it's 16 plus 3 is 19, and from J it's 19 plus 15, which is 34. We will take the higher duration, which is 34, in order to represent the earliest starting possible time for node number 8. For node number 9, there are 2 times coming from the 2 arrows directing to node 9, which is 16 plus 5, that is 21, and the 26 plus 2, that is 28. So we will take the higher duration, which is 28, in order to represent the most early starting time for any activity that is coming out from node number 9, which is P here in our case. Now we are going to node number 10, which is the last one. It's receiving 3 times, as you can see, one from the dummy activity, and one from activity P, and one from activity O. The one from the dummy is the same 34, and one from activity B is 28 plus 3, that is 31, and the one from activity O is 26 plus 4, that is 30. Here, if we take 30 or 31 as our choice, this will mean that there are some activities in the project that are not completely finished. So we cannot say that the project is finished except when all the activities are completely finished. So we will take the higher duration, which is 34. This is how we calculate the time early, or the earliest possible starting times, from the left hand side to the right hand side. The second type of time that we are going to calculate will be on the opposite way. We will start by reflecting the last triangle we get in a higher or a lower circle that we will draw, like you can see now, in a higher circle or a lower circle with the same duration that we reached. Here we reached at 34, so the time late, which will represent the latest allowable starting time for the project, which here represents the end of the project, will be the same as the number we reached at the earliest possible starting time, which is here in our example is 34. So we will reflect the number that we reach to in the circle, and we will start deducting. We will start from here to deduct the times in an opposite way from what we did in the previous ones, and we will write each late time in a circle above or under the rectangle that represents the earliest possible starting time. So for node 10, the latest possible starting time is 34. As for node 8, we will deduct 0, which is the time of the dummy activity, from 34, so it is the same 34. For node number 9, we will deduct 3 from 34. It will give us 31, and we will deduct these times from each other, the earliest possible starting and the latest possible starting, which will give us the slack times that will be written in an triangle, like you can see here, with the outcome of the deduction of both the time in the rectangle and the time in the circle. Here at node 9, the slack time is 3. At node number 7, the node is receiving back 2 times, one from node 9 that is connecting activity N, and one from node 10 that is connecting activity O. So we will see which time we will select. The first one is from node 10 to node 7, that is 34 minus 4, that is 30. But the time from node 9 is 31 minus 2, that is 29. Here, when we deduct, we will choose the lower amount. Here 29 represent the latest possible starting time that is allowed for any activity that is starting from node 7, meaning that this means for activity N and O that the latest possible starting time for them is 29 weeks. When we reach to week 29, we shouldn't be late than 29 in order to start activity N and activity O and have the project as a whole done at the end of the 34 weeks without delaying it. If we choose 30, this will mean that I can delay starting activity N and activity O until we reach to week 30, which will affect the whole network, which will affect the whole project will delay the finishing of the whole project, because here activity N will if we supposingly يعني started at week 30 and activity N will take 2 weeks, so this means that we are in week 32 and we didn't even start activity B that will take 3 more weeks. So if we choose the number 30 instead of 29, this will mean that the whole project will be delayed by 1 more week. So here, when we are deducting the times, we will select the lower amount. So here we write at the circle of node 7, 29, and the difference between the early start and the late start that represents the slack time. The flexibility in the early start and the late start is 3. This will lead us to node number 6. Node number 6 is receiving times from L, M, and K. So we will deduct 34 minus 3 and 31 minus 5 and 29 minus 4. This will give us 25, 31, and 26. So when we compare these times, we will select the lower amount or the lowest amount, which is 25, in order to represent the latest allowable possible starting time for node number 6, which will give us 9 weeks as slack time between the earliest possible start and the latest possible start. This will lead us to node number 5, which is receiving only one time from node number 8, which is 34 minus 15, will give us 19 weeks. Going to node number 4 now. The node is receiving only one time from activity I, which is 29 minus 9, which will give us 20 with a slack of 3 weeks. Going now to node number 3, we will calculate the times given by the arrows. Here we have 3 activities, G, H, and E, giving times back to node number 3. So it is 19 minus 8 and 25 minus 5 and 20 minus 6, which will give us 20 and 11 and 14 to compare between these times, and we will select 11 to be the lowest amount with a slack of 0 that is written in the triangle, as you can see. Going to node number 2, we have 19 from node number 5 minus 4. This will give us 15, and we have 11 from node number 3 minus 6. This will give us 11 minus 6, that will give us 5. So the comparison goes in favor of 5 weeks with a slack of 0. Going back to node number 1, we will compare 5 minus 5 and 11 minus 7 and 20 minus 10. So the lowest amount will be 0. Here at node number 1, at each time you will start with 0 time in the rectangle, and you will reach to 0 time in the circle, and you will reach to 0 time in the slack time. So when you start node 1 times, you always start with 0, 0, 0, like you can see. And when you reach to the end of the network, you take the duration of that is written on the rectangle, you reflect it in the circle, and you start deducting like we did now. So here this is the PERT network with all the kind of information that we need: when to start an activity, when to have some kind of flexibility in making a late start in some kind of activities, which activities that are critical. Here, as you can see, the same path that we selected at the previous section, which is A, B, G, J, and dummy. These activities will have 0 slack times from the beginning and the end of each one of them. So activity A will have 0 slack time before and 0 slack time after it. Activity D will have 0 slack time at node 2 and it's activity D. 0 slack time at node 2 and 0 slack time at node 3. Activity G will have 0 slack time at node 3 and 0 slack time at node 5, etc., till the end of the network, as you can see. Now we go to the rest of the questions relating to the numbers we calculated now. So question number 6 asks for the times for event 1. Like we said, event 1 is the beginning of the project, will have 3 zeros. So the answer here is A, which have 0 earliest possible starting time, and 0 latest possible starting time, and 0 slack. The times of event 3, like you can see from the network that we calculated, is 11, 11, 0. So the answer is C. Question number 8, times for event 6 are, when we look at the network, event 6 has 16, 25, and 9. This will represent letter C. And the times for event 8 are 34, 34, and 0, which is letter D. And times for event 10 are 34, 34, 4, and 0, that is letter C. For question 11, times for event 8 and 10 are the same because they are connected with a dummy activity, as you can see from the PERT network that we do. Question number 12, 1 day delay in any of the critical activities will, as we said, critical activities, why did we call them critical? They are the activities on the network with the highest duration, which means that any delay in any one of these activities will make the whole project get delayed. So if we have just 1 week delay in any of the activities here in our network, will make the whole duration not 34, it will make it 35, 36, etc. So 1 day delay in any of the critical activities will increase the total duration by the same delay. So the answer here is B. Question number 13, 1 day delay in any of the non-critical activities. If we stopped here, the answer will be, well, no effect on the total duration of the network. But we will continue the question. 1 day delay in any of the non-critical activities more than the slack time. So we can delay the starting of any activity that have slack time. But if we delayed more than the slack time, what will happen to the whole duration of the project? It will increase the total duration by the same delay. So the answer here is B. This will lead us to question number 2, which requires us to fill in a table, like you can see, with activity letters and the time for each activity, and going through late finishing time and early finishing time and the slack time. The slack time is the difference between LF and EF, late finish and early finish times. Okay, from which part of the network can we get the late finishing time, and from which part of the network can we get the early finishing time of each activity? The late finishing time is the time that is written at the end of the activity in the circle, that is the latest possible starting time at the end of the activity that is being asked for. Here for activity A, it will take 5 weeks. The late finish for activity A from the network is 5. It is written at node number 2 in the circle above that node. Or by calculation, the late finish time for activity A is 0 plus 5, which is the time given. And what will be the early finishing time for activity A? Here the early finishing time will represent the earliest possible starting time that is written in a rectangle at the beginning of the activity plus its duration plus t, its time. Here is 0 plus 5 as well. So this will give us slack time for this activity 0. So this activity is a critical one. Any delay for just 1 week in the start of this activity will make the whole project to get delayed by the same time. As for activity B, its time is 7. These times are given in the table at the start of the exercise. So these times are already given to you. And we said the late finishing time you will find at the end of each activity. You calculated it at the circle written above that node. And the early finishing time you will calculate it as the early start plus the duration of each activity, or you will find it at the rectangle before that activity. So for activity B, the late finish is 11. You can find this 11 for activity B at the circle that is drawn for activity 3. Sorry, not 3. And the early finishing time is 7. That is 0 plus 7. And the slack time here is 4. As for activity C, the time is 10. The late finish is 20. The early finish is 10. The slack time is 10. And you complete the whole table to be just the way given to you in the model answer. Here we can say that we finished PERT network. We finished discussing the earliest possible starting time, the latest possible starting time, and the slack times, and we knew how to get our critical path and which are the activities that are on the critical path. So thank you for watching, and leave any question you have in the comments, and have our best wishes.